Hi guys, so they want us to find the nodal equation for this particular circuit. So the first thing I'm going to use is KCL. KCL was used to find the nodal equations. KCL is basically saying that the sum of currents going into a particular node is equal to the sum of currents exiting that particular node. As simple as that. I'm going to be using a formula, Ohm's formula, to represent current in the circuit when all we have is voltage and resistors. So R is basically the resistor the current is passing through. The first thing you want to do is you want to first identify the nodes. Now, before I would have said this and that, this and that, this and that, this and that, and this and that, but I'm not so wrong. But these three nodes are connected by just a wire. There's no element in between them, which means they are not different. It's just a piece of wire. So this entire nodes can be grouped as one node, and the same can go for this as well. Now at node V1, it's simply going to be what is the current that's entering? 5 amps is entering it here. When the 5 amps enters this, it's going to exit at this point, and also at this point. So 5 amps is equals to, that's the current entering. The current exiting is this one. That will be V1, because that's the higher current, minus the lower current. Everything here is 0 volts. So minus 0 over 2 plus, same goes for this one, V1, because still in that same V1 category, over 5 plus the last one is this one. This one, the voltage in between it is V1 and V2. It's going to be V1 minus V2 all over 2 ohms. So I'm going to multiply through with 10. That's going to be 50 equals to 5V1 plus 2V1 plus 5V1 minus 5V2. You simplify this equation, you're going to get 12V1 minus 5V2 equals to minus 50. So this is our first equation. The next question is at node V2. What is entering this node? This current. What is exiting? This one. But notice this current direction. You have to pay attention to current direction. It's saying that I am coming into this node. So this is coming in, this is coming in, and this will exit. So for the R for is going to be V1 minus V2 over 2 ohms as we previously established, plus the 3 amps that is also coming in, equals to what is exiting this node. The node is V2 0, so it's V2 minus 0 over 4. I'm going to simply multiply through with 4 to simplify the equation. It's going to give us 2V1 minus 2V2 plus 4 times 3, 12 equals to V2. Simplify this equation, you will get 2V1 minus 3V2 equals to minus 12. This is our second equation. Now these are simultaneous equations. You can simply solve them and you get your answers. V1 equals to minus 3.4615 volts and V2 is equals to 1.6923. The minus is just showing the direction of the voltage. It's nothing too huge. Thank you for listening.